continuing the next part in the inlet design. Okay, so in the previous part of the video I have discussed about the location of the case study example, that is Brigade Road of Bangalore. Okay, and discussed about its catchment hydrology and what would be my the inlet strategy to mitigate the local inundation of flood. Okay, so continuing the next part, so in this video I will show you the sample design calculation to fix this drainage issue. Okay, so here I'm going into this hydraulic toolbox software, and initially I will design this first on grade inlet. Okay, and calculate how much will be the intercepted flow and remaining flow, which is not unintercepted, nothing but the bypass flow. Okay, that bypass flow I will deduct in the designing of the insag inlet. Okay, so let's start that here. Okay, I will use this hydraulic toolbox. So this is the user interface of hydraulic toolbox, and I will change the units to international standard unit, that is SI. Okay, in metric system. Okay, so here I will add this new curb and gutter analysis. Okay, so here I will add this curb and the gutter inlet data. Okay, so the longitudinal slope of the road, so longitudinal slope of the road is 5%, so 5%, sorry, 0.5%, so 0.5% is nothing but 0.05. okay, the cross slope, the road cross slope, I am assuming 0.02. okay, and roughness, it's a asphaltic road, and I am considering the Manning's roughness coefficient of 0.015. okay, the design flow, so design flow as I shown in the this presentation, so it is 0.21. okay, so 0.21 will be my design flow. okay, 0.21. okay, and the gutter width, I am keeping gutter width as 1 feet nearly, so 1 feet is nothing but approximately 0.3 meters. okay, and compute the unknown, so I computed the spread at this location, so without the inlets. okay, this is actually the spread, it's 5.17 meters the spread without the inlet. okay, now I will design this inlet here. So inlet, so first inlet what I am designing is the on grade inlet. So this on grade inlet is nothing but the first inlet, is on grade inlet. So either of them, so both of them I am designing at a time. okay, so I will get a flow, the intercepted flow from one inlet I multiplied by 2. okay, and remaining total flow minus intercepted flow will give me the total design discharge which is coming into this insag inlet. okay, so I have created a this table for this one. okay, so my total design flow would be 0.21. okay, so for the I will calculate the how much flow which is having captured by one on grade inlet. okay, and I will multiply by 2 because we are having the two on grade inlet having the similar road geography, road geometry and elevation. So that is why the on grade total on grade flow remaining the sum of these two on grade inlets. okay, the total intercepted flow. okay, so first start here. okay, so it will be inlet type would be grate. So it will be grate opening, and grate type, as I mentioned earlier, it will be like reticuline type of the grate. So reticuline shape is nothing but the honeycombing shape. So this will be my type of the inlet which I am using here, is honeycombing type of inlet. okay, and the grate width and depth, I am using the standard 1.5 by 1.5 with a grate width. okay, so 0.45 by 0.45. okay, so this is the standard size which I taken from the local material supply for the grades. okay, So now I am computing this flow. So how much flow it is showing. So if you can clearly show, the intercepted flow is 0.055, okay, and the remaining will be the bypass flow, okay. So this flow is nothing but from one inlet. It is this bypass flow from one inlet. Whatever the flow, it is not intercepted, it is goes into the next inlet. That is nothing but the sag inlet here. So what I have done as of now, I have calculated the sizing of this inlet, okay. So this inlet is having the intercepted flow of 0.055, okay, and the next whatever the flow which is not intercepted is going to the next inlet. So that is nothing but the 0.055, okay. So same I will multiply it into 2. So 2 since we have the 2 in on grade inlets, so I will multiply it by 2, okay. So here the bypass flow is 0.0 the intercepted flow is 0.055, okay. This is from a single on grade inlet, so it is 0.055, okay. And from the 2 on grade inlet, so I need to multiply 2 into the single on grade inlet intercepted ray capacity, it is 0.11. So the total okay, let me share the two. That means the total bypass flow towards the sag inlet, okay. So towards the sag inlet is 0.21. So that's nothing but the design peak flow discharge, okay, minus the total intercepted flow from the on grade inlets. There are 2 on grade inlets, so the interception capacity of a single on grade inlet is 0.05. When you multiply by 2, it will become 0.11 Q max, okay. So this actually my design capacity of the inside inlet. So this is actually the bypass flow which is coming into the inside inlet. So for that I need to design. So I need to design this sag inlet in such a way that it should carry this 0.1 Q max of the discharge rate, okay. I'll keep it in decimal. So this is actually in the decimal rate, okay. And now let's move to the inside inlet design, okay. So I have designed this on grade inlet. So this is actually the size of the on grade inlet. The type is the reticulin grades, okay. So I'll mention the sizes of on grade inlet is equals to 0.45 meter by 0.45 meter reticulin grades, okay. So this is the sizes of this is of the on grade inlet sizes, 2 numbers, because we are providing 2, right, 2 numbers of reticulin grades, okay. That's we have as of now we have designed for the on grade inlet, okay. Now this sag inlet. So sag inlet, we know that our target flow is nothing but this one, that is 0.1 Q max, okay, and the road condition will be remaining the same as on grade, okay. So let's move to this on grade, okay. I'll design this for inside inlet. So inside inlet I will design it, okay. So here so let's design the inside inlet, okay. So here I opened the hydraulic toolbox once again, okay. So the road geometry will be remaining the same. Okay, only thing which will be changing is the design flow, as I computed from the previous on grade inlet. So it will be 0.1 q max. Okay, calculate the unknown. So it is spread without the inlet. Okay, and now what I have to do, I have to design the inlet, insag inlet. So here I have to change this inlet on grade to insag inlet. Okay, regarding the percentage clogging, so in the insag inlet there's a high chances of the clogging system due to the some floating elements and some debris. There is a high chances of clogging system in the insag inlet. Okay, so I will consider some percentage of clogging here. So in the insag inlet, so I am considering 20% of the clogging. Okay, and the grate type will be remaining the same. It will be grates and reticulin type of the grate structure. Okay, I mentioned about the reticulin type, that is nothing but the honeycombing, and the grate sizes will be the standard 0.4 by 0.45. Okay, so let's compute it, these sizes, whether it is capable of taking this flow or not. Okay, so now what I can see, so here it's area we have computed, and depth at the center of the grate, and the flow is 45. So what I will do, so here so depth at the center of the grate, so it is slightly, I believe it is slightly on the higher side. So it look like this. If I draw that here, paint, so I am drawing that. So this is okay, so this is that road curve. Okay, so this is the crown of the road, and from here it is will be road curve, curve, and here is the footpath. Okay, my inlet is coming somewhere here. This is the insag inlet. Okay, so this is my insag inlet. Okay, and I am getting the water depth for the design case is around 1.146 meters. So depth at the center of the grate, so 0.146. So that 0.146 is more than the curve height. So curve height will be around 0.15 or nearly 0.10 centimeter or the 15 centimeter. So if even if I assume the 10 centimeter, okay, there's a possibility that if it rises to 0.45, there's nothing but the 14 centimeter, so it will may flood this one, right? So it will flood this case. Okay, this is around having the 0.145 or 14 centimeter, 0.145 meter. Okay, you can see this one is 0.146. so what I have to do, I have to provide one more inlet here, a double inlet. A double inlet will work. Let me check that. So I will propose a double inlet here. Okay, so what I will do, I will increase its size to double. Okay, 0.45 to 0.99. okay, let me try this. Okay, so here I got this depth at the center of the inlet. Okay, now the depth at the center of the inlet is 0.92. okay, so this curve height is itself is road curve height itself is at 10 centimeter. Okay, 10 centimeter or the 0.1 meter. So now I am getting 0.092. so that is very much satisfactory results it's giving. Okay, so let's finalize my results. So my sizes for the inlet would be insag inlet would be 0.45 by 0.45 double inlets. Okay, so this is not a single inlets, will be like 0.45 by 0.45 double inlets, because there is no option of giving number of double inlets, insag inlets. So what I have to do, I have to consider the double the size of the grate width and grate length. Okay, so let's mention about the inlet sizes, inside inlet sizes. Okay, the sizes of inside inlet double 0.45 meter by 0.45 meter reticulin grades. Okay, so this is how we have done this exercise. Okay, hope you understood. If you have any questions on this, please let me know, or you can comment in my video. So thank you for watching.